Let's see how we can be able to prevent deadlock in operating system. So these are all the some of the conditions in which our deadlock will be occurring. So let's check with the condition and what are all the approaches that we can be able to use to prevent this condition. So this is the thing that we are going to check. First thing is mutual exclusion. So generally mutual exclusion, the approach that we will be using is pooling to remove, and we have hold and wait. So generally what hold and wait will be doing is it will request for all the resources initially and it will wait until the resource will be getting executed. So that's how it will be actually working. And we have no preemption. So no preemption is generally it will snatch all the resources, which is nothing but it will pick up the resource and wait until other resources will be getting executed. And we have circular wait, so within which all the priority of the resources will be ordered, so which will be actually ordered in the way of numerical way. So this is how it will be actually executed. We have 4 different types of deadlock strategies that will be executing. Let's continue with deadlocks handling strategies. So how we can be able to handle the deadlock, so that we are going to see. So for that we have deadlock prevention, deadlock avoidance, deadlock detection and recovery, and deadlock ignorance. So these are all the some of the strategies through which we can be able to handle the deadlock. So take for example, before seeing all these things, let's check with the context switching. So context switching is generally a process in which we will be storing the state of a thread, so that we can be able to restore or resume the exception at a later point. So we can be able to do that. We know that like context switching is generally the most expensive of the CPU utilization. So whenever we were about to execute, so that will be the most expensive thing. And we have context switching between 2 threads will be the same process, which is faster than between 2 process, because it shares the same virtual memory. So that's why. Okay, so as it shares the same virtual memory, so it will be actually very faster. So that's the thing that why we'll be using context switching. Then we can be able to see what is meant by a deadlock. So deadlock is generally a condition where 2 resources are sharing the same resource and are effectively preventing each other accessing the resource. So generally, take for example, I have P1 and P2. P1 will be holding the resource R1 and it will wait until resource R2 will be getting executed. So okay, so this is how it will be executing. P1 will hold the resource R2 and it will also wait R1 to be getting released from P2. So that's how it will be actually getting. So 2 processes will be sharing the same resource to be getting executed. Okay, so let's check with some of the deadlock conditions, so through which the deadlock conditions might be occurring. So take for example, we have these 3 types. So what is mutual exclusion in the sense? P1 will wait. So take for example, all the resources in this case are non-shareable. So this is the major thing. What will happen is only one resource can be able to use one resource at a time. So one process can be able to use one resource at a time is mutual exclusion. And we have hold and wait, so which is nothing but one process is holding one resource and wait for another resource. So this is what we will be calling it as hold and wait. What will be happening is P1 will hold R1 and it will request to R2. P2 will hold R2 and it will request for R2. It will be holding one resource and waiting for another resource, so such that both will not be getting executed. So this is the actual thing. What is no preemption in the sense, take for example, the resource can be voluntarily released by the process until the resource release doesn't occur. So like the resource will be actually released until the resource release will not occur. So in this case only no preemption will be occurring. So it will not willing to give up R1, P1 resource will not willing to give up R1. So in this condition only no preemption will be occurring. And we have circular wait, so it will be a very interesting thing. So with which A will be waiting for B until B will be really B will be executed. So A will be waiting for B until B will be executed. B will be waiting for C until C will be executed. C will be waiting for A until A will be executed. So this is how circularly it will be waiting for each other. So at this condition, so whenever all these resources are not getting executed, so each and everything will be waiting for one another, and finally there the thread will not totally will be getting executed. So this is the major thing that will be happening. That's it.